let's see, is this going to give me information I want? RTR 2 with a rotate. Okay, so here's a little more information about how R behaves. Can we think of formulas that might behave a little like that? Well, what I want, I'm sort of saying, if we start with some number x and we do t to it, it adds 1. So this is always true, okay? What I'm looking for is a similar kind of a formula. I want to have something here, a formula involving x. Okay? So, well, if this is the only thing you knew in the world, that r takes 1 to -1, then there are all kinds of formulas that would work, right? It could be that r simply multiplies by -1. But that doesn't work because if r multiplied by -1, you can find a place that doesn't work. Two twists and a rotate should be -2. So 2 twists, a rotate, 2 twists should get you back to 0, but that's not the case. So it's certainly true that r does not multiply by -1. What other things could r do to take, I mean, what formulas can you think that take r 1 to -1? -1 over x, that's a good guess. I mean, you can test them, though. That's the nice thing about a lot of these. Like, let me skip that for a sec, get back to that. But it could be that r subtracts 2, right? If this is the only thing you know, r could subtract 2. How could you test that? You could start at 0, do a rotate. You should be at -2, but we're certainly, if r always subtracted 2, then we start with 0. If we did a rotate, this would be -2, and you can test that it's not -2, because if it were -2, 2 twists would get you to 0, but they don't. 2 twists leave you in exactly the same shape. So r can't be subtract 2 as the operation. And then there was a nice suggestion here that r maybe takes x to -1 over x. Does that work in these? It works in this case, well, 3 cases, right? Yeah, I mean, in this weird division kind of sense, right? I mean, if r, this certainly works here, right? R certainly takes 1 to -1 over, -1 over 1 is -1, so this one works. -1 over 0 should be something that behaves like -infinity. And -1 over -infinity, in other words, if you start with 1 and you put a huge number down here, you get something very close to 0. So if I put, in some sense, an infinite thing here, I get back to 0. Okay? Yeah.
So I think I know the answer to this, but I want to make sure. So right now, this is 0 here, right?
Yes.
And the green is in back and the yellow's in front.
Right.
Now, if we had the yellow in back and the green in front, I would still consider that 0.
Yes.
Okay, so that means we know that r squared do 2 r's.
Well, yeah, two r's would get you to the same thing. And that also works here, right? If you do r and then r again, what I'm looking for now is, this is a good guess. It fits all of the data so far, right? This formula here, where r takes x to -1 over x, it fits our 3 pieces of data so far. We've actually got more things we can test it on, but we do know some other things. Namely, well, one thing is trivial, is that r to the 4th does what? If we do 4 rotates, what's going to happen? We're obviously exactly back to where we start.
But in answer to my question just now, r squared does the same thing.
R squared does the same thing. Well, okay, so we can check. What does r squared do? R followed by r. We start with x. We do a single r. Where are we? -1 over x. Now, if I do an r to -1 over x, what do I get? -1 over -1 over x, which is x. So it looks like r squared doesn't do anything. R squared is the identity. So in other words, if you do 2 r's in a row, if this is the correct formula, you're in business. And clearly, if 2 r's get you back to where you are, then 4 r's will get you back twice. Okay? So in other words, this thing is also compatible with the r to the fourth. Okay, and let's try one of these. Let's see if RTT gets us back to 0. So we did 2 twists, so we got to 2, and we know, because we've messed around with the ropes, that RTT gets us back to 0. So if we do an R, where are we? Negative 1/2. Now I do a T. That T does always adds 1, so negative 1/2 plus 1 should get us to positive 1/2. Okay? Then I do an R. That's negative 1 over 1/2, which is negative 2. And then the T squared, adds 1 more, and we're back to 0. So in other words, this formula works here. Just for the heck of it, let's do 3. I mean, it won't be a proof of anything, but so what do we do? An RT. R gets us to negative 1/3. A T gets you to adds 1 to negative 1/3, so that'll get you to 2/3. And now I do an RTT. So R, negative 3/2, TT, RTT, right? So we have to add 1 and add 1 again. That'll be add 2 total. So this will be positive 1/2. Yep. So the TT gets us to positive 1/2. Then what do we do? Another RTT. R goes to negative 2, and then the TT gets us back to 0. So in other words, the formula works here, the formula works here. Isn't that sort of neat? I mean, could we try it with? Do we dare try it with n? Let's. Okay, yeah, okay. You guys can sit down.